Okay, um, sometime today I've been messing about with sorting out room renderer. So I've done a load of testing, um, which I've shown in the other videos, and got the lookup working and all that sort of stuff. So what I wanted to do is actually take unpacked room data and see if I could actually write the render code that traversed it. And I'll show you how you have to traverse it in order to draw it in the right way. You've got to draw it from front to back, top to bottom. Okay, so it's actually quite complicated. It's a 2D array, so it's just like a table, but you've got to run across the table diagonally. So it's actually um, a little bit trickier. It's not just a matter of incrementing rows and columns. There's a weird sequence which you can't see until you write it down. And I was looking at this and I came up with a data-driven way of doing it. And then I showed it to my better half, who's a mathematician, and she looked at it and went, "Oh, you just subtract 7." So she spotted this pattern that was there, which was really awesome. So I've implemented that. I would have got there eventually. I would have seen it. I could see there was -7, but it didn't just stick in my head. Um, but anyway, by the by, so I'll show you a couple of rooms, and then I'll put a breakpoint in I can show how the renderer actually renders a scene. Okay, so if I just run this, it'll draw the first room that I've got defined. Okay, so you can see it's not optimized. It takes quite a while to draw the room, fair few frames, which so you can see it running. Probably about a second, so probably about 50, 60 frames it's taking, probably a little bit more. Um, so there's a room rendered. It's not a full room, that one. That was just that was one of the ones I was using to test, which I showed partly something like that in the last video. So I'll just press, it's interactive this now. So I'll just press play once start and I'll move on to the next room if I've selected the main window. Right, so let's just press 1. Okay, little path test room there. Okay, so it's got some flat floor tiles and stuff. A more complicated one, which I call the arrow room. It looks hideous, but it was set up to test compound tiles. So, and I'll show you the next one, and then I'm going to put the breakpoint into render it. Okay, so let me just put the breakpoint in. Oh, if I can get the cursor to come back to main. So BP75A. Right, so I'll just carry on running this. That's running. Right, so let's draw the next room. So this is a full room, gridded. It's got a couple of levels. Each room is 7 by 7 wide, but it can be 8 objects high. Okay, so you can actually represent quite complicated room layouts. Okay, so it's drawn the backmost tile from the lowest floor. Okay, so what I do is I draw every tile that's in a column. So you'll see this. So I've got one tile, but I think there's another tile on top, so it'll draw that one next. So when I go back to main and tell it to run to the next breakpoint, you'll see that it starts drawing the next tile. Then we have to move left and we go diagonally across a diamond. I call it a diamond renderer because that's how it's working through the data. So we've done the back one, then we've done the 2 either side, and we go all the way up the columns there. Next, we're going to step across and we'll do 3 columns. So you'll see this. So there's the first column, second column, that's only got a half tile, that one. Third column, then I draw 4 columns across. That's got sloping in that one. So you can see these building up. So I'm stopping as I draw each object. Main's not doing the dirty check, so I think sometimes it's like half drawn on the debugger. So the next row will be 5 columns that are checked. So this is diagonally going through a 2D array. There you go. And you can see that the confound lookup's working. So there's another slope goes on top of that. And again, look, you can see on that last one, there's no red line. Like I say, that's saving me tiles on me lookups. So keep going. Do 6 this time, and then we've got the full width row. So the 7 columns have to be parsed and drawn for that one. Now we come back to, we start decreasing again. So we'll do 6. And there you go. Then we'll do 5. And you have to do it in this order. If you don't do it like this, then you get issues with the compound tiles. So you've got to try and make sure you're always drawing in front of stuff that's there. And that's the final one. Okay, so what I'm going to do is I'm going to go through some more maps. I'll do it a bit quicker, but I'm going to use the breakpoint. So let's just generate the next one. So these next 4 are actually from, or they're my versions of the maps from Spin Dizzy. Okay, they're my versions because I think I had to resize. I think Spin Dizzy uses 8x8, and I've got a vertical screen, so I can only get 7 across. So I've gone 7x7. So if I just run through this one, you'll see this one getting built. So this, I quite like this one on Spin Dizzy, just like little hops over gaps. Okay, so again, you saw how it was rendered. Let's move to the next one. So breakpoint. So that was rendering a full height one. So you see bang. So that's the full height of the level. Obviously the sprite can go above that. So it can run along the top of that tile if I want it to. Well, when I write all that code. So I really like these levels because they got really nice slopes that are curvy. Even though there's no curves, it actually, your eye thinks they are. So I really like these. I always like these levels in Spin Dizzy. So you can see there's a nice little zigzaggy path. Next one. Let's go back. Oh, I've left OBS open there. It's going to look stupid. Right, okay, let's do the next one. Another nice Spin Dizzy one with curves. And again, you've seen it build up tile by tile. It's the reason it's not very fast is because for every single time I draw a tile, I'm having to look up stuff in that compound list, and that's implemented at the moment as a really, really slow linear search. Okay, through quite a lot of data. So I've got to do that. That's obviously a key optimization. None of the other code's optimized. I just want to get it working before I start hacking at it. Okay, really like that level. That's really nice. I like that one. And the final one is a quite cute level. I can't represent these Spin Dizzy ones exactly because I haven't got enough tiles to make the compound tiles up. So I have to make some compromises. I can't have like the water floors on some levels because I just can't represent all the tiles. If I had twice as many tiles, I could probably represent most of the Spin Dizzy levels. But you've got to make compromises when you're doing things that you can't do on hardware that wasn't designed to do what you're doing. Okay, but this is quite a nice little complex one. So you got all these like jumpy paths on this one. So this will be a good one to test when I'm actually controlling the Gerald character and getting the gravity set up right and the slopes and the speed on the slopes and everything. And that's where I'm at. So the next thing I really want to do is do the view changer so I can rotate from this view to the other 3 directions you can view the level from. So that's really just a matter of working out the sequences again and coming up with a little algorithm to implement those sequences. But that's where I've got to. There you go, Spin Dizzy isometric 3D. No interaction with the player at the minute, but that's isometric 3D worlds rendered on Pac-Man hardware. Okay, thank you very much.